Okay, so let me finish this chapter. Math 2400, lecture 19, continuous random variable 7. Weibull, log-normal, and beta distributions. Now, X is Weibull alpha and beta. It has two parameters if the PDF is this. Now let's find the CDF. It's interesting. If you look at this, you will see that it's not hard to find its CDF. So the CDF is what? So the CDF of X is P of X less than or equal to X, say that is integral from, well, it starts at 0 in fact because it's 0 for X less than 0, so this is from 0 to X alpha over beta alpha t to power alpha minus 1 e minus t over beta to power alpha dt. So I'm using t as a dummy variable because I'm using X here. And so, as you see, well, let me just let u be this thing, t over beta to power alpha. Then x, this t goes from 0 to x, so this gives me that u goes from 0 to x over beta to power alpha, right? So the limits for t is 0x, the limits for u is 0 and x over beta alpha. Now, if I said this, then du will be alpha over beta to power alpha t to power alpha minus 1. So you see that this is in fact the derivative of this. Not with negative, I mean with positive. So the integral will become, so fx will be integral from 0 to this guy, x over beta alpha, and e to power minus u du. That's it. So let me erase this and write it here. So fx will be this integral. So it will be minus e to power minus u from 0 to this, x over beta to power alpha. So it will be 1 minus e to power minus x over beta to power alpha. And that's x bigger than or equal to 0. Okay, so, and it's 0. From negative infinity to 0, it's 0. So let's start that. Okay, so that's it. We have it's say CDF. Now, if we look at this, let's see. Do you see like the exponential distribution here? First of all, it looks like gamma distribution, but it's not gamma distribution. So it is a different family of distribution. I never mentioned family of distributions. I mean, never used the term. But when we say gamma, for example, alpha beta or Weibull alpha beta, we are talking about a family of distributions. And when we will see in the statistics that you have to choose. For example, some distribution, so we just assume that certain thing is obeys certain distribution, and then you gather data and you find those parameters using your data and some method you find those parameters. So we will see that anyway. So let's just introduce these here and find the CDFs or PDFs or whatever, and then that comes next. So that was this one. Oh, I said, do you see exponential distribution here? So exponential distribution is e to the power minus x or some lambda x, right? So what do we have here? So exponential distribution exp lambda is has fx equals lambda e to the power minus lambda, say x. Let's use x so it looks like that. So what do we have here? So I can say that exponential lambda is in fact equal to Weibull. Okay. Here there's no x here, don't see x, so alpha is 1, right? 1. And beta is 1 over, alpha is 1, so beta should be 1 over lambda, right? So that is in fact, and you see it's in fact, if you write 1 over lambda, lambda goes up here and you will get lambda here. So that's in fact this. And I also wrote down exponential distribution as some kind of gamma distribution. So it's interesting that exponential distribution is some kind of gamma distribution and also some kind of Weibull distribution. So yeah, that's nice in fact. Okay, so that was the first one. Lognormal. Let me use this. Let me see, Lognormal. Lognormal. So we say that x is lognormal mu and sigma squared if y equals ln of x. Usually they write log. They don't use ln anymore in higher mathematics. So they just write log and they mean ln. So this is normal mu and sigma squared. Okay, so let's try to find the PDF of this because we have some extra information here. So y is normal, right? So let's see. I have this. So we need PDF of x defined is CDF, then differentiate the CDF. So the derivative of CDF is PDF if it's continuous. So let's see. So we need fx, which is probability that x is less than or equal to x. And look, this when we talk about ln of x, x should be non-negative. In fact, no, positive, just not negative, positive. So x should be positive. Otherwise, log of 0 is not defined. So it should be positive. So now this is saying that p of let's find ln. So this is positive, so we have ln of x. Ln is an increasing function, so if x is less than x, ln x is less than ln x, right? That's for increasing functions, and but this is in fact y. This is y. So this means that this integral is 1 over square root of 2 pi sigma integral from minus infinity to this point ln x. That's the definition. E to power minus say y minus mu squared over 2 sigma squared dy. Right? Okay, so what is the derivative of this? So we know that the derivative of this fx, which is df dx, that is the PDF. So remember the derivative, I found the general formula for you last time. So it is derivative of d dx of ln x times e to power minus, just plug in this here, ln x minus mu squared over 2 sigma squared. This ln x is simply d dx, that's 1 over x, so we will get this PDF. So let me continue here. So fx, the PDF, will be this thing. So d dx of ln is 1 over x, so we get 1 over 2 pi sigma, x comes here, the denominator, e to power minus ln x minus mu squared over 2 sigma squared. Okay, and x is definitely bigger than 0, and it's 0 otherwise. So this is 0 otherwise. So when I say x is in some say interval, and I don't write 0 otherwise, it's like I'm implicitly saying that it is 0 otherwise, right? So so that is the log normal, and sometimes this one is useful because normal distribution doesn't work, and you just use log normal instead of normal distribution. So we will see that in stats where this thing is used. Now it's just defining it. Okay, the last one is beta distribution, another important distribution, especially used a lot in like deep learning, machine learning, and other places. So, okay, beta, we say that this is beta and it has two parameters, alpha and beta, if it has PDF of the form fx is gamma, gamma alpha plus beta times x to power alpha minus 1, 1 minus x to power beta minus 1, and x is in 0 and 1, and it's 0 otherwise. Okay. Well, it's not hard to find the mu and sigma for this thing. Mu is alpha over alpha plus beta, and sigma squared is in fact alpha beta over, I guess, alpha plus beta squared something. Oh, no, let's look at this and remember in binomial distribution, binomial, we have n and p was the probability. So binomial had the PMF of this form. PMF was like n, say, something, x, p to power x, 1 minus p to power n minus x. So if you look at this thing and compare here, compare with this, and let me erase this x and write p. So it looks like that. You see, this part looks like this. Alpha minus 1, beta minus 1, and that is x n minus x, right? So, in a sense, this is telling me that maybe when they started with this and they came up with beta distribution as some kind of extension to something. In fact, I'm not saying that's the case, but the beta distribution is used to model this P, in fact, probability. So, because you see it supports this, 0 and 1. So, it's 0 everywhere except in that interval. So, it is in fact used to model probabilities and that's one important area. So that's why I said at the beginning that it has great many applications in, say, deep learning and machine learning and so on other places, and also in statistics when it comes to when we are dealing with binomial or some kind of distribution which has some probability as valuable as a parameter, say. So, yeah, this beta distribution has a general form, and that general form is when this interval is not 0, 1. It's like some other interval, like a, b. So let me write down that the general form of beta distribution, and that's it. That is, in fact, the last thing I want to say. And okay, so let me. So we say that x is beta. Well, let me use the notation in the book. We'll use A and B if it has PDF. So the PDF will be f of, say, let's not write p because then this is not probability anymore if A and B are not 0, 1. So that is, in fact, G I have no formula, that's the wrong formula, so let me just copy from here 1 over B minus A, gamma alpha plus beta, gamma alpha, gamma beta times x minus A, B minus A, alpha minus 1 times b minus x. Oh, I guess that's b minus x. Yeah, that's right. B minus a to power beta minus 1. And that's if x is in this interval a, b. And this means that a is less than b and 0 otherwise. Okay, so that is like the general form of beta distribution, not only for that interval 0, 1, it's defined on interval a, b, and it has this form. And it's not hard to show that, in fact, if I just pick this, and if I want to find this constant, it's not hard to see that the constant is in fact that gamma alpha plus beta over that. So anyway, well, with this, I guess I'm basically done with this chapter, and next chapter will be on distributions beyond one variable. So that is multivariate distributions, and we need lots of other things from Calc 1, 2, and 3. So, okay, so that's it for today, and see you next time.